Good evening, everyone. My name is Laura Kaminsky, and I'm the Program Administrator for the Michigan Clean Water Corps. I'm here with Dr. Paul Steen, my Corps Program Manager, and we are pleased to welcome you to this year's CLMP training webinar.
Hi, everybody. My name is Paul Steen. I'm the Program Manager for the Cooperative Lakes Monitoring Program. I hope you're all having a good start to the month of May. We had our in-person training last week at Boyne, and it was a great conference attended by many people, but we're happy to be able to provide a chance for other people who couldn't make it to still get some training in. We're running things a little different. This is new for us this year to run pre-recorded videos first and follow it up with question and answer. And we realize that this isn't personal and lacks some of the naturalness that a regular presentation would give, but in this way, I would basically be saying the same things, and I'm a lot now I can't have the opportunity to forget anything. So you'll know that you're getting all the right information, and nothing will be left out. So what we'll do is we'll run each of these videos, and then according to the agenda, we'll move to question and answer, and definitely participate in the Q&A, because that's what will make this webinar more interesting for everybody. So with that, we're going to start up with the Secchi disc video first.
This video gives a procedure on how to take a Secchi disc measurement for the Cooperative Lakes Monitoring Program, often called the CLMP. The CLMP is a program of the Michigan Department of Environmental Quality and supported by numerous partners. About 230 Michigan inland lakes participate in the CLMP every year. My name is Paul Steen, and I am the Program Manager for my Corps, the umbrella program that manages the CLMP. If you have any questions about my Corps or the CLMP, you can email me at the address shown. Anyone interested in participating in the CLMP must enroll their lake into the program every year. There is a registration fee for every parameter, and some of the parameters have equipment costs. You can register online or learn more at the website given here. You may also contact the person listed here for any registration-related questions. This video is meant to be supplemental to the written procedures. If you plan to take Secchi measurements this summer, be sure to review the written procedures and datasheet prior to starting. All of the paperwork you need can be obtained from the My Corps website at the address shown here. Look for the section on Secchi disc transparency to find the procedures and the datasheet. A Secchi disc is an 8-inch circle disc divided into 4 black and white quadrants. The Secchi disc is one of the oldest pieces of equipment in the study of lakes. In 1865, an Italian scientist by the name of Angelo Secchi invented the disc to measure the transparency of the Mediterranean Sea. Volunteers taking Secchi disc measurements in the CLMP start the measurements in the middle of May and continue them until the middle of September. Optimally, a volunteer will take 1 measurement per week through the whole summer in order to produce the best data. However, the minimum required effort is 8 measurements. No matter how many measurements are taken, they need to be spaced evenly through the summer to produce results that reflect the lake's average summer conditions. For example, taking 8 measurements in May and June and failing to take measurements from July to September would not accurately reflect the lake's summer conditions, and this data would not be accepted. The exact schedule for Secchi disc measurements for any particular year is given on the Secchi disc transparency data form. Every lake that registers in the CLMP is given a number that represents the sampling location for that lake. This number, called the field ID number, is associated with the latitude and longitude of the deepest location in the lake. All of the sampling done on this lake should be conducted at this location. When you are ready to take a measurement, head out on your boat to the sample point. Because the boat can disturb the water, it is best to turn off the engine and drop anchor upwind of the sample location and then drift to the proper location. On calm days, coast into the proper location and wait several minutes for the water to settle. Taking a Secchi disc measurement is a very simple process. First, lower the disc slowly until it disappears from view. Note the depth of the water at which the disc disappears. Second, slowly raise the disc back up until you can see it again. Note this depth also. Average both depths to obtain the official Secchi disc measurement. This is the value that you record on your datasheet. Round to the nearest half foot. There are several things to remember when taking Secchi disc measurements. First, remember to take those sunglasses off. Anything affecting the amount of light reaching your eyes will detract from the accuracy of your measurements. Second, if it is a sunny day, take the measurement in the shadow of the boat. A measurement taken in direct sunlight will be different than a measurement taken in the shade. To be consistent, CLMP volunteers always take a shady measurement whenever possible. Third, be consistent. The best time to take a measurement is between 10 a.m. and 4 p.m. Pick a time in this window and do it at the same time every week. Conduct the measurement on a sunny, calm day when no heavy rain, wind, or excessive boating has occurred prior to sampling. Be sure to completely fill out your data form. The top section contains the basic information for your lake, and the grid gives a monitoring schedule as well as the location to record your measurement. On the back of the data form, draw an outline of the lake and indicate monitoring station and maximum depth. On the bottom, there are boxes to indicate whether you entered the Secchi disc data into the CLMP online database or if the data was not entered. Please check the appropriate box. No matter which box you check, please mail a copy of your data form to the address given. The CLMP keeps a hard copy of all data collected in the program. The online database where all the CLMP data is stored is called the MyCore Data Exchange. This database allows you to enter your data, view the data from your lake, and see the data from all of the other lakes who have ever been enrolled in the CLMP. The MyCore Data Exchange can be found on the MyCore website. To enter your own lake data, contact the person listed here for a username and password. It is very easy to enter your own data. You will fill out boxes in a manner that is about the same as purchasing something off of an internet website. By choosing to enter your own data, you can save the CLMP a lot of staff time and help keep lake registration costs down. At the end of the year, you'll receive a data report that shows a long-term transparency trend of your lake. This data is valuable in showing you, other lake residents, and the Michigan DEQ if there are ongoing threats to the lake's water quality. Remember, the yearly average can only be calculated if you take at least 8 measurements and spread them evenly throughout the dates given on the data sheet. Thanks for watching, and we hope this video was helpful for reminding you how to take Secchi disc measurements in the Cooperative Lakes Monitoring Program.
Hi everyone, we are now going to resume with the total phosphorus.
Phosphorus is an essential nutrient for life. Phosphorus is generally in short supply in freshwater systems, meaning that the rate of plant growth is controlled by the amount of phosphorus available. Human activities tend to introduce excessive phosphorus into lakes and streams, and this can cause algae blooms. Blue-green algae blooms can produce toxins into the water that can sicken or kill people and pets. The decomposition of algae blooms will use up the dissolved oxygen in the water, causing fish kills. Phosphorus is found in a variety of forms in freshwater systems. It is dissolved in the water, in the tissues of dead and living plants and animals, and absorbed to soil particles. To obtain a total phosphorus measurement, all of these materials are digested with acid in the laboratory to free the phosphate molecule. which is then measured as a concentration in terms of micrograms per liter, also called parts per billion. The CLMP provides the opportunity to take 2 phosphorus measurements every year, one in the spring and one in the late summer. The spring sample is taken after the ice melts off of a lake and the lake is fully mixed. This sample will represent the total amount of phosphorus in the whole lake. The summer phosphorus sample is taken during the late summer after most lakes have formed layers of warm surface water and cold bottom water. This sample represents the top layer only, and it controls the summer algae production in the lake. There is no set date for spring phosphorus sampling. The goal is to sample the lake within 2 weeks after ice has entirely disappeared from the lake's surface. Since every lake will have a slightly different date of ice out, it is up to the volunteer to determine this date. Please note that this is a change from past years, when CLMP staff attempted to predict the ice out date for the lakes. However, lake residents are best suited for determining ice out for their lake, and this programmatic change will result in samples that more accurately reflect spring turnover conditions. The summer phosphorus sample needs to be taken in August or September, with the date range depending on the county in which your lake is located. These dates are listed on the summer phosphorus schedule. Every lake that registers in the CLMP is given a number that represents the sampling location for that lake. This number, called the field ID number, is associated with the latitude and longitude of the deepest location in the lake. All of the sampling done on this lake should be conducted at this location. When you are ready to take a measurement, head out on your boat to the sample point. Because the boat can disturb the water, it is best to turn off the engine and drop anchor upwind of the sample location, and then drift to the proper location. On calm days, coast into the proper location and then wait several minutes for the water to settle. Prior to sampling, fill out the 2 sample labels as shown and attach the labels to the bottles. You must use a permanent black marker to do this because water-soluble ink will run when it gets wet. In the box for parameter code, write GA. On the second label, write REP in the location box, indicating that this is for the replicate sample. All volunteers will take 2 water samples. Using only the sample bottles provided, remove the cap of one bottle, being careful not to touch or contaminate the inside of the bottle cap or bottle. Grab the bottle at the bottom and rinse twice. No dust or dirt particles should be in the bottle, but just in case, rinsing the bottle removes anything that may have gotten into it. To fill the bottle, lower the bottle with the opening pointed down to a 1 or 2 foot depth, a little longer than the length of your forearm. Once the bottle is underwater at the proper depth, rotate it upwards to release the trapped air and allow water to enter. Repeat this sampling procedure with a second bottle to obtain a replicate sample. Pour some water out of the bottle to avoid cracking the bottle when you freeze the water sample. Put the bottles in a baggie and place them in a cooler bag with a freezer ice pack. As soon as you return to shore, put the water samples in the freezer and leave them there until it is time to turn the samples in. All samples must be turned and frozen or they will be rejected. Be sure to completely fill out your data form. Use a black permanent marker or a pencil. On the back of the data form, draw an outline of the lake and indicate monitoring station and maximum depth. On the bottom, there are boxes to indicate whether you enter the phosphorus sampling information into the CLMP online database or if that information was not entered. Please check the appropriate box. No matter which box you check, put your filled out datasheet into a baggie and place it into the larger bag with your frozen samples prior to turning in your sample. The online database where all the CLMP data is stored is called the MyCore Data Exchange. This database allows you to enter your data, view the data from your lake, and and see the data from all of the other lakes who have ever been enrolled in the CLMP. The MyCore Data Exchange can be found on the MyCore website. You may be wondering what data you could enter into the database for a phosphorus sample, since your water sample needs to be analyzed by the DEQ Water Lab before you learn the phosphorus results. However, the sampling information on your datasheet, like the field ID number, the sample date, and lake name, all need to get entered into the data exchange. Once the lab has analyzed your sample, CLMP staff will match the sampling information to the lab results, and it will all be viewable on the data exchange. To enter your lake data, contact the person listed here for a username and password. It is very easy to enter your own data. You will fill out boxes in a manner that is about the same as purchasing something off of an internet website. By choosing to enter your own data, you can save the CLMP a lot of staff time and help keep lake registration costs down. Each lake is assigned to a sample drop-off location depending on the county in which the lake is located. There are 2 turn-in dates for phosphorus, one for the spring phosphorus sample and another for the summer phosphorus sample. Refer to the phosphorus schedules to get your assigned drop-off location and dates. All samples must be turned in frozen, include the data form, and arrive prior to noon on the assigned date. At the end of the year, you will receive a data report that gives your phosphorus results and the long-term trends of your lake. This data is valuable in showing both you, other lake residents, and the Michigan DEQ if there are ongoing threats to the lake's water quality. Thanks for watching, and we hope this video was helpful for reminding you how to take total phosphorus samples in the Cooperative Lakes Monitoring Program.
Okay, welcome back everyone. 6:40, and we are going to start the chlorophyll video.
Chlorophyll is the green photosynthetic pigment found in algae and other plants. Chlorophyll is an important indicator because it directly represents the amount of algae in a lake. Lakes that produce a lot of algae are higher in nutrients, and if levels get too high, the lake can be in danger of undesirable algae blooms and fish kills. There are various forms of chlorophyll. We check for Chlorophyll-a in the CLMP. It consists of a hydrocarbon molecule with a tail and ring structure, and this ring is held together by an atom of magnesium. Chlorophyll-a is the most common form of chlorophyll found in the algae in lakes in Michigan and the upper Midwest. You will take 5 samples per year for Chlorophyll-a, once a month from May through September. Some lakes located in northern Michigan will be scheduled to take their September sample in late August. To see the exact dates for lakes in your county, refer to the chlorophyll schedule. Make every attempt to collect all 5 chlorophyll samples in order to get the most representative data for your lake's summer conditions. At least 4 samples must be taken in order for us to calculate averages and enter the data into a long-term trend graph. This is an example of a depth-integrated composite water sampler that volunteers use in the CLMP. Before heading out on the lake, make sure that all of the pieces are accounted for. After getting to your proper sampling location, disassemble the sampler and rinse the large amber bottle with lake water. Be careful not to lose any parts of your sampler. It happens to someone every year. After rinsing, reassemble the sampler. The next step is to take a Secchi disc measurement. View our Secchi disc video to review those step-by-step instructions. Sunlight is able to penetrate into water about twice the Secchi depth. Since our goal is to get a water sample that contains algae from the entire water column where it is possible for algae to grow, we need to lower our integrated water sampler to twice the Secchi depth. Use a clothespin to mark the measured line at twice the Secchi depth. If you are sampling in a lake where twice the Secchi depth would be greater than the total lake depth, mark your line with the clothespin at 3 feet less than the total lake depth. so that when you release the sampler, it does not hit the bottom of the lake. Put the measured line in the water to avoid the line getting tangled when sampling. Then, hold the sampler at the water's surface and let it go, allowing it to free fall through the water column until the clothespin is at the water surface. When the line is taut, retrieve the sampler at a slow, steady rate. Check the water level in your bottle. You want the bottle to be more than half full, but not completely full. If the bottle is completely full, or it's less than half full, repeat your sampling. You'll have to adjust the rate of your retrieval. Adjusting the level of the glass tubes in the bottle stopper may also help water enter the bottle more or less easily. All of this takes some practice, and several tries may be necessary until you find the method that works best for your lake. Swirl the sample bottle to gently mix the water, and then use a small portion of the sample to rinse the 2 rectangular amber bottles. After rinsing, fill both of your rectangular bottles with the water sample to just below the neck. Take the magnesium carbonate dropper bottle and shake it vigorously. Add 5 drops of magnesium carbonate to the chlorophyll sample in each bottle and swirl gently to mix. This magnesium carbonate acts as a preservative. Finally, store the rectangular bottles in a cooler bag with an ice pack out of the direct light. You have successfully collected the water sample. Now it's time to go back to shore and filter it. The best place to filter a chlorophyll sample is indoors, by a sink, and out of direct sunlight. Make sure you have all of the equipment listed. Ready to go? First, unscrew and open the filter holder. Use tweezers to pick up and move the filter. Never use your fingers. The filter is a glossy and opaque white circle. Be sure not to use the filter separators, which are translucent and look more like tissue paper. Center the filter on the screen and place the O-ring on top of the filter. Screw the filter holder back together until it is moderately tight and place it to the side for the moment. Grab the syringe and the small piece of clear plastic tubing. You can push the tubing onto the syringe. It doesn't fit perfectly, but it will not slip off if you work at it. Swirl or invert one of the amber bottles to mix. Rinse the syringe by drawing up sample water until the syringe is full, and then empty it. Then, fill it up to the 60 milliliter line. With the syringe pointing up, tap it to force air bubbles to the top. Push the syringe plunger until the end of the plunger is lined up with the 50 milliliter mark. Attach the filter holder to the syringe. Like the tubing, it won't snap into place, but you can get it to fit snugly. Slowly push the chlorophyll sample through the filter holder and adjust your pressure to achieve a rapid drop rate. Pushing too hard may rip the filter, so avoid excessive pressure. As you push the plunger, make sure that no water is leaking out the side of the filter holder. If your sample has a lot of algae or other particles in it, it may become too difficult to push the full 50 milliliters of sample through the filter. In these situations, stop pushing and note how much water you were able to filter by reading the side of the syringe. There is a place on the datasheet for you to record this information. After filtering the water, separate the filter holder from the syringe and unscrew it. Using a safety pin and tweezers, fold the filter in quarters with the algae on the inside. The filter will probably stick a bit to the filter holder, and it requires a steady hand and some practice to do this job smoothly. Remember, never touch the filter with your fingers. Put the folded filter into a sample vial and cap it. Place a filled-out sample label onto the vial lengthwise so that none of the label is wrapped upon itself. Let's take a look at what a correctly filled-out sample label looks like. You need to use a fine-tipped, permanent black marker to fill out the sample labels. In addition to the basic lake information, write CA in the parameter code box and write MgCO3, which stands for magnesium carbonate, into chemicals added. Remember, you added magnesium carbonate in an earlier step. On the label for your second sample, write REP next to the lake name. This is short for replicate. You now have one sample complete. Congratulations! Now you get to do it all over again with your second sample bottle. Once both samples are complete, wrap the vials completely with aluminum foil to keep all light out. This foil wrapping step is critical. Unwrapped samples cannot be accepted for laboratory analysis. Write your lake's name and the sample month on the foil packet. The samples go into a Ziploc bag with your lake name, county, and field ID number. Fold the data sheet, place it into a separate Ziploc bag so it stays dry, and place it in the bag with your samples. Storing your data sheet with the samples is a good way to make sure the paperwork never gets lost. And then everything goes into the freezer until it is time to turn it in. Each lake is assigned to a sample drop-off location depending on the county in which the lake is located. There are 2 turn-in dates for Chlorophyll-a. The first sample turn-in will include your May, June, and July chlorophyll samples, and the turn-in date will fall near the end of July. The second turn-in will include your August and September chlorophyll samples, as well as the summer phosphorus sample if your lake is enrolled in summer phosphorus. This turn-in date will be sometime in September. To find the exact dates and turn-in location for your lake, please see the chlorophyll schedule. Remember, all samples must be turned in frozen and must be received prior to noon on the scheduled date. At the end of the field season, your chlorophyll results will be ready. Remember that at least 4 samples must be received in order for us to calculate averages and enter the data into a long-term trend graph for your lake. Thanks for watching. We hope this video was helpful for reminding you how to collect a Chlorophyll-a sample in the Cooperative Lakes Monitoring Program.
Okay, thanks for listening to the chlorophyll training. This is definitely a more complicated process than Secchi and Phosphorus, given the water collection phase followed up by the filtering. So it takes a little bit of detail orientation. It's helpful to have the procedures right there next to you while you're doing the filtering especially. So make sure you have those printed out or have access to your laptop or something right there by the sink. Because it's a lot of numbers. Fill up to this line, push it out until this line, all that. So you do have to be careful on that to make sure you get it right. We
actually do have a question.
Okay.
Would you like me to read it?
Yes, go ahead.
So the question we received is, I expect to have a lake Secchi depth of 15 feet with a max lake depth of 18 feet. Is that going to be a sample problem, or do I merely sample at 15 feet and note the issue?
Right. So for chlorophyll, the directions are that you go down to twice the Secchi depth to get the water sample. If you can't do that because your lake isn't deep enough, then you just go down as deep as you can, and there's a spot on the data sheet where you record what that depth is. So in your case, you would drop it down to 18 feet, and then you can write 18 feet on your data sheet. Now you want to be careful when you do that you're not actually hitting the bottom really hard. So actually what I would recommend is, you lower it to about 17.5 or so and do it from there so you're not hitting the muck on the bottom. Let me know if that didn't answer your question.
And if you have a follow-up question, feel free to raise your hand and we can open the line. Oh, so it does answer.
Okay, good. Yeah, that's really good. Actually, that is often asked, and I should just add it into the training, so thank you for that. Hi, everyone, and welcome to the Score the Shore session for this webinar training. This video will last about 30 minutes because it includes a lot of detail, a lot of pictures and specific examples of what you expect to see when you're out there doing this habitat assessment. So with that level of detail, get your questions down right away before you forget them, or write them down on a piece of paper. Make sure that we get those any questions that you have addressed. So with that, enjoy this training video.
Shorelines are an important component of every lake. They are the primary habitat area for most of a lake's animals. Birds, amphibians, reptiles, insects, and fish all rely on the shallow water and the aquatic terrestrial vegetation along the edge to find food and a safe place to rear their young. Healthy shorelines help maintain water quality, limit erosion, and slow rain runoff. However, shorelines are threatened on most lakes where people live and recreate. Houses and everything associated with them often eliminate the important components of a healthy shoreline. Lawns, rocks, and seawalls remove optimal habitat locations. Foot traffic, docks, and the desire for an unobstructed view of the lake remove vegetation that stops erosion. The Score the Shore assessment is a standardized method that aids lake residents in finding problematic habitat areas on their lakes. To do this, a team of 3 to 4 people will troll around the edge of the lake and judge the health of the shoreline using a scoring form. The shoreline is broken into 1,000-foot sections that are scored individually. The first step in the Score the Shore process is to break your shoreline into the approximately 1,000-foot sections. The sections don't have to be exactly 1,000 feet, just close to it. You need to do this before you begin the survey. We recommend using an aerial map to first produce a rough sketch of where the 1,000-foot sections will fall. Then, cruise around the lake in your boat and pinpoint specific landmarks, like a house or a dock, that indicate the exact start and stop of each section. The second step is to print the data sheets. You only need 1 copy of the survey cover sheet, but you will need many copies of the survey data form. Each 1,000-foot section will require several of these data forms, depending on how many people make up your team. They are available at the website shown. The third step is to gather your equipment. Here is a list of what is needed or suggested for the assessment. Most of the use of this equipment is self-evident. One thing to highlight is the tally counter, or clicker. You will use these to count houses, docks, and woody debris, and it'll be a big time saver. To properly assess the lake, it needs to have plants or vegetative growth. Therefore, it is recommended to wait until at least mid-June before starting and finish before mid-September. Otherwise, the exact timing of when to conduct the assessment is up to you. The size of your lake will determine how long it will take to finish the assessment. On a small lake, the assessment may only take a couple of hours, but it could take several days on a large lake. Plan on each 1,000-foot section taking at least 30 minutes. As your team gets better at its job, this number will go down. Finally, you should repeat this survey occasionally. We recommend doing the survey every 3 to 5 years on your lake. Based on our experience working with teams and volunteers on the water, you'll find in the Score the Shore procedures that we include a recommended process for your team to follow while scoring the shoreline sections. This process tends to work efficiently for teams. It follows the sequence of items on the scoring form and allows you to get a good view of the shoreline features you need to assess. You may find a different process that works well for your team on your lake. Let's review this general recommended process now. An efficient Score the Shore team should consist of at least 3 people. One person whose primary responsibility is driving the boat, and 2 others focused on assessing the shoreline features. Navigate to your chosen starting point at the beginning of your first 1,000-foot shoreline section. Plan to make at least 3 passes back and forth in your boat along this 1,000-foot section. For the first pass, position the boat about 100 yards offshore. This will allow you a view where you can see most of the 1,000-foot section at once. You'll then make a second pass closer to shore, about 20 to 30 feet out. The final pass will be back out at about 100 yards from the shore. Every team member, except potentially the driver, should be provided with a stack of scoring forms, one for each 1,000-foot section, and will record answers to the questions. The driver can idle the boat while the team discusses answers to the various questions and reaches agreement. One person should record the final answers. This is the survey cover sheet. It includes general information about the survey. Record the lake name, county, and townships, as well as the lake sampling site, or field ID, number. Record the names of all the team members and the date of the survey. It's okay to conduct the survey over multiple days. Just record all the dates on this cover sheet. Lake level at the time of the survey can influence some of your observations. Indicate whether the lake level during the survey was average, or normal, low, or high. Some lakes have a legally mandated lake level that is managed by a dam. If your lake has a legal lake level, check yes on the cover sheet and indicate the measurement at the level gauge near the outlet at the time of the survey if possible. There is also space for you to comment on whether the lake level impacted the survey results. For example, if the water level is quite high during the survey, it may make it difficult to see certain shoreline features because they may be underwater. If possible, the survey should be conducted during normal lake level conditions. The bottom half of the survey cover sheet should be filled in when your survey is complete. Here you will record the total number of 1,000-foot shoreline sections that were surveyed on your lake. If the final section surveyed was substantially shorter than 1,000 feet, you can record the approximate length here. Note whether photographs were taken as part of the survey. Photos can be really helpful for comparing conditions over time and can help you look back and answer questions you may have about the survey. However, photographs are not required. Calculate the development density and overall shore score for your lake by following the instructions in the box. Development density around a lake and the overall shore score are often related. Now, let's take a look at the scoring form itself. Your report will include one of these scoring forms for each 1,000-foot section on your lake. At the top of the form, record the section number. This is very important. Also record the lake name, county, and date. While recording the lake name on every sheet may seem redundant, it's critical to include this information on every form for statewide record keeping. Then record GPS coordinates or a landmark that indicates the starting point for this 1,000-foot shoreline section. Refrain from using people's full names, for example, John Smith's house, on the scoring forms, out of considerations for your neighbor's privacy. Copies of these forms will be stored by the MyCore program forever. The scoring form is laid out with the expectation that your team will follow the 3-pass process we outlined earlier. Recall that you don't have to do the survey this way, but many teams have found that it works well. First, we'll review this entire scoring form. Next, we'll look at photographs and examples of the types of things you might see along the shoreline of your lake and examples of how to fill out this form. But first, back to the form. For Pass 1, you should keep your boat about 100 yards from shore. Cruise along the shoreline and count the number of homes and major buildings and the number of docks and boat lifts. When you reach the end of Pass 1, make sure that everyone on the team agrees where this shoreline section ends. Next, head back in the opposite direction, closer to shore, for Pass 2. You should be 20 to 30 yards out, so you can see the shoreline features well. You'll be looking at the littoral zone features and shoreline erosion. The littoral zone is the underwater area close to shore. The handy diagram in the upper right corner of the sheet will help you remember this. First question, what percentage of the 1,000-foot section exhibits emergent or floating vegetation? Emergent vegetation are aquatic plants that stick up out of the water. This would include reeds and pickerel weed. Floating vegetation typically is water lilies. Your options include none, less than 10% of the total 1,000-foot section, 10 to 25%, 25 to 75%, or more than 75%. Notice that after each choice is a number in parentheses. This is the number of points the section earns for each option. No need to worry about those points now. You'll add them up later, back on shore. The next question asks you to estimate how much of the shoreline exhibits submerged vegetation. Those would be underwater plants like coontail and milfoil. If the water isn't clear enough for you to make this estimate, simply check Unable to See. The next question asks you if aquatic plant management is evident or known. That is, can you see or do you know that plants have been sprayed, harvested, or otherwise removed along this 1,000-foot section? If not, choose No. Otherwise, select Minor if there's some weed management around docks and swim areas, or Major if practically all the plant life in the lake near shore has been treated or removed. Next, estimate the amount of downed trees or other woody debris, like branches or logs, along this 1,000-foot section. Your choices are none, a few, that is 1 to 5 trees or branches, several, or many. Your last observation during this second pass, close to shore, is to estimate how much erosion you observe along this 1,000-foot section. None, minor, moderate, or severe. We recognize this is a judgment call on your part, but that's what we're looking for, your team's opinion about the extent of erosion in this section. For Pass 3, take the boat back out to about 100 yards from shore for the final observations. First, estimate the percentage of maintained lawn, beach, and impervious surface along the 1,000-foot section. Don't count naturally sandy shoreline as maintained beach. Impervious surface refers to areas where rainwater can't soak in, pavement or pavers without space between them. What percentage of the 1,000-foot section is unmowed vegetation? That's vegetation other than lawn, such as brush, trees, or weedy overgrowth. Next, about how deep does that unmowed vegetation extend back from the water's edge? Less than 10 feet? 10 to 40 feet back from shore? More? The final section refers to erosion control practices that you see along the shoreline. Are people doing things to stop erosion? The categories include vertical artificial, which includes any kind of vertical structure that people have installed, including metal seawalls or rock walls. Sloped artificial includes sloped structures or materials placed on the shoreline. Common examples include concrete or rocks. Finally, is there any bioengineering evident? This includes use of natural materials to stop erosion, like bundles of branches or core logs, which are long bundles of coconut fibers. Once your team has answered these questions, it is time to record the GPS coordinates or landmark at the end of the section. Again, don't take time to add up scores now. That can be done when you're back on shore. On the back of each section's datasheet, you'll find space for scoring and comments. This math scales all of your scores to a 0 to 100 point range to aid in their interpretation. Many lakes may be turbid enough or have bad lighting conditions so you can't see the submerged vegetation. If that is the case for your lake, use the alternative equation shown. This equation takes submerged vegetation out of the final score altogether. If you have comments or concerns about this section of shoreline or about the survey itself, you can include them in the space provided here. Beginning back at the top of the data form, we'll now look at photographic examples of each feature you'll be looking for. Remember, the assessment is done on 1,000-foot sections as a whole, not lot by lot. You'll see that most of the upcoming photos show single lots, but that's just for illustration purposes. We recommend beginning Pass 1 about 100 yards from shore to count homes and major buildings and docks. During this pass, you can also make sure that everyone on the survey team agrees where the section begins and ends. When you count the number of docks and boat lifts in your 1,000-foot section, a dock with an attached boat lift, like this one, just counts as one. Now, make a second pass along the section closer to shore, as conditions allow for safe navigation. This may be about 20 to 30 yards from shore. This photograph shows emergent and floating vegetation. The reeds closer to the shoreline are emergent plants. They grow up out of the water. The water lilies in the foreground are floating vegetation. Here's another example of a littoral area in the lake that has both floating and emergent vegetation. This photo shows floating algae on the surface of a lake. This floating algae can be counted as floating vegetation. Here's an example of submerged vegetation. Submerged vegetation may come close to the surface. Small flowers or other reproductive structures may break the surface, but the rest is underwater and counts as submerged vegetation. Submerged vegetation may also be far beneath the surface, growing low against the lake bottom. Now, let's look at evidence of aquatic plant management. A single bubbler like this is minor aquatic plant management. The constant disturbance by bubbles prevents floating plants and other vegetation from taking root in a small area. Mechanical harvesting across an entire section or much of it would be considered major management activity. Weed roller use in a few places along a section could be considered minor, but if everyone's doing it, leading to nearly continuous removal of aquatic vegetation, then you can call it major. What should you count as downed trees and woody debris? Partially or fully submerged wood counts. If the lake is unusually low during the survey, feel free to count wood that is currently exposed but would normally be at least partially submerged. Concentrate your counting on pieces 3 inches or larger in diameter. Don't worry about counting the twigs. This fallen tree is only partially in the water, but it counts if it's in the water at all. Wood near the lakeshore can provide valuable cover for fish and other wildlife. Here's another example of wood in the water. These are definitely big enough to count. Here's another interesting example. Some wood you encounter may have been placed on purpose to control erosion. If that's the case, you can count it here, but we'll also be able to consider it when you're assessing erosion control later on in the data form. Now, let's look at evidence of erosion. This is an example of a small area of erosion. Include erosion that is clearly the result of human activity, as well as erosion that may be caused by forces of nature, like wind, waves, or ice. This situation is commonly seen. There is erosion all along this stretch of lakeshore. It's probably not severe, that is, the hillside isn't about to fall in, but likely moderate, since it is happening along a long stretch, and it appears that the property owner is trying to stop it by placing some rocks along the shore. Here is another example of moderate erosion. The tree isn't falling into the lake yet, and erosion is likely slow and gradual. However, if you are familiar with this property and happen to know that in the spring there was no erosion at all, you would be justified in calling this severe erosion because you know it's happening rapidly. Here's another example of moderate erosion. The sloped lawn shows clear evidence of erosion, likely because they are trying to maintain lawn on a steep slope, but there are no major cave-ins or slumps. This hill slope is actively eroding. For this small stretch, erosion seems severe. This property seems to have no vegetation on the slope and has the potential for serious erosion. Consider approaching nearer to take a closer look. Is there evidence of active erosion? Should a beach area be counted as erosion? Only if there are active signs of the sand being lost to the lake. If your lake is naturally sandy, sand beaches may be a natural feature and should not be counted as erosion. Now, let's head back out further from shore, like 100 yards out, for our final pass. You'll now assess the riparian zone, that land near the shore, and erosion control practices. Maintained lawn refers to turf grass or other vegetation that is regularly mowed for use or appearance as lawn. In this example, we see maintained lawn as well as a small impervious walkway. Remember, impervious means water cannot penetrate. For this assessment, you will judge the percentage of the section length that is lawn, artificial beach, and impervious all together. Here's an interesting example where you can clearly see maintained lawn and a parking lot, which is impervious surface, along the shoreline. This patio is another example of impervious surface. The gravel and mulch around it is not impervious. Water can soak through, but the pavers create a section of impervious surface. This patio is entirely impervious. This lot exhibits maintained lawn and an artificial beach. We know it is an artificial beach because the shoreline of this lake is not naturally sandy. The sand is likely brought in by the homeowner for a small swimming area. This lot includes an artificial beach and artificial erosion control. Now we're looking at some good stuff, unmowed vegetation. Look at two characteristics. First, what percentage of the 1,000-foot section has unmowed vegetation? And that can include any vegetation, tall grasses, wildflowers, weeds, shrubs, and trees. Second, on average, how deep is that belt of unmowed vegetation? That is, how far does it stretch back from the water's edge? This one appears to stretch back less than 10 feet. There appears to be some rock that has been placed at the base of this unmowed vegetation belt. That's okay. We can comment on that under the shoreline erosion control practices section. This vegetation should still be counted under unmowed vegetation. Here's another unmowed vegetation belt. It's not very deep, but it's there. This lot includes gravel, rock, and beds of unmowed vegetation. You can consider the entire lot to have a belt of unmowed vegetation, even though there is some exposed gravel. The depth of the unmowed vegetation belt on this lot is fairly deep. It appears to be more than 10 feet, but probably less than 40 feet. This lot is heavily wooded. If vegetation is growing densely enough that you can't see through it, you can safely say that it is greater than 40 foot deep. This section of shoreline exhibits a couple of different depths of unmowed vegetation. On your left-hand side, the unmowed vegetation starts as shrubby growth along the shoreline and becomes forest further back. It's definitely more than 40 feet deep. On your right-hand side, there's just a narrow strip of unmowed vegetation behind the dock before the lawn. This is easily less than 10 feet. Now, let's look at some shoreline erosion control practices, starting with artificial erosion control, like steel and rock. Vertical artificial practices include structures like metal seawalls, vertical boulders, and rock walls. This picture shows a vertical seawall. Here is another example of a long metal seawall. This vertical seawall is made from concrete. Large boulders and vertical walls of rock are also considered vertical artificial structures. Here we have a vertical boulder wall in front of a concrete seawall. Structure like this one should also be considered vertical. Even though there is some slope to the boulders in front of the seawall, it doesn't pass what we call the turtle test. We like to reference the turtle test for determining whether erosion control structure is vertical or sloped. If a turtle in the lake has no chance of making it up onto dry land, it's probably vertical. What do you think of this type of erosion control? Even though it's fairly low, it still should be considered vertical. Think of that little turtle. Now, let's look at some examples of sloped artificial erosion control practices. This can include concrete in smooth or broken pieces and riprap or smaller rocks. A turtle might struggle here too, but at least it has a chance when it comes to sloped artificial control practices. Here's an example of extensive sloped artificial erosion control created from concrete block. Sloped riprap is quite common along many lake shorelines. It passes the turtle test. Here you can see a lot lined with sloped rock. Their neighbor has installed a vertical steel seawall. Even a small amount of rock or riprap should be considered when you estimate the overall percentage of sloped artificial erosion control in the 1,000-foot section you are working on. And be sure to count it even if there is unmowed vegetation growing on top of it or behind it. Is this an example of sloped or vertical artificial erosion control? At the foot of the slope, where it reaches the water, it is sloped rock or riprap. There are vertical rock walls that create terraces upland of the riprap. Try the turtle test. The turtle should be able to make it to dry land. Call it sloped. Even though there are rocks or riprap piled up against the seawall in this example, it should be counted as vertical seawall. What about this example? In this case, you may be able to count it as sloped. At least in the more distant part of this picture, our turtle may be able to make the transition. Remember, just use your best judgment on these categories. Work with your team to agree upon how to record what you observe. Finally, let's look at some examples of bioengineering or soft engineering erosion control. What you see here are core logs, long bundles of coconut or other natural fibers designed to stop erosion. Note that while these areas don't get a positive score on the data form, like a natural shoreline would, the score is less negative than artificial structures, because although erosion is being managed, it is being dealt with in a way that eventually, with proper maintenance, will be indistinguishable from natural shoreline. The shoreline will be recovered at that point. On a related note, if you know of an area where bioengineering was installed years ago and now most people wouldn't be able to tell that it ever happened, that is, it looks natural now, then that shoreline area should be considered natural and not included in your percentage of shoreline with evident bioengineering. Here's a closer look at core logs in action. Note the vegetation planted between the logs. The roots of those plants will eventually take over the job of erosion control. Core logs are sometimes installed along great lengths of shoreline. Stumps and bundles of brush or branches are also used for bioengineered erosion control. Remember this picture from the woody debris section? You can also include this stretch in your assessment of the extent of bioengineering erosion control in this section. What about stuff like this? You can definitely see some artificial erosion control going on here, and it looks like it would pass the turtle test. We'll call it sloped artificial. One more example. What do you see here? From this angle, it looks like our turtle would have a tough time making it over this wood material. If that's the case, it doesn't pass the turtle test, and you can call it vertical artificial. Now for some last bits of advice. Photographs can be immensely useful for documenting your observations. Here are some helpful rules for ensuring that your photos will be useful for you. First, take lots of pictures. Discard any that are blurry or out of focus. And be sure to incorporate a method for recording the location where each photo was taken. This can be done in a number of ways, such as recording the photo number on your data sheet for that section, or taking a picture of the section number, perhaps written on a piece of paper or dry erase board, before you begin photographing that section of shoreline. Your Score the Shore report should be submitted to MyCore by the October 30 annual deadline. The Score the Shore procedures include the details of where to send your complete report, which should include a completed survey cover sheet, a set of all data forms. There should be one for each 1,000-foot section on your lake, a map of your lake showing the locations of each section, and finally, any photographs you'd like to submit. Be sure to make a copy for your records before submitting your report to MyCore. So what good is all this information anyway? The results from this survey are not regulatory and not intended to be as enforcement for what people can or can't do on their property. However, the assessment is a valuable educational tool. You can share your results with neighbors and give tips on how lake residents can help improve scores. We recommend newsletter articles, talks at neighborhood and association meetings, and friendly conversations. It's also valuable if you're able to repeat the survey. You may see areas where your lake has improved or gotten worse over time. Thanks for watching. We hope that this video accomplished our goal of instructing you on how to conduct a Score the Shore assessment in the Cooperative Lakes Monitoring Program.
Okay. All right. Well, thanks everyone for going through that training session. There's a couple questions. First, I just wanted to say that last week when I was at the Michigan Inland Lakes Conference, lakeshore habitat quality was probably one of the most often things talked about. So I think there's this growing understanding that this is a major issue facing Michigan lakes. Actually, I saw one presentation that was put on by the DEQ, and it was 2012 National Lake Assessments, and they had a Michigan-specific part of that, and they listed about 10 different stressors that Michigan lakes are going through, and the top stressor for Michigan lakes was listed as lakeshore development. So this very thing that we're talking about. So more so than phosphorus and more so even than invasive species, the EPA was finding that this issue is the thing that we most have to worry about going into the future. So I thought that was interesting and kind of shows the value of what you're going to be doing this summer if you're following this assessment. So Linda had a question. Do you want me to read it?
Okay. So the question is, if our lake does herbiciding, will this affect the outcome of the Score the Shore results?
So Linda asked that question before the slides came up, so you probably saw the answer to that. Yes. The answer is yes. It will negatively affect the score for each reach. If you do a lake-wide herbicide treatment, then you would lose 2 points basically on that category for every single lake section.
And then there's a follow-up question. Should we do the Score the Shore before herbiciding?
Yeah, so that's a good question, and I'm glad you wrote it early, so it gave me time to think about it. So I think the best thing to do in that case would be, yes, to do the assessment before the herbiciding. And then, if you have time, to revisit it after everything has had time to die off. And you don't have to redo the whole assessment, but you could just go through and answer the questions that are in regard to plants. So you could look at, I think there's three, there's the submergent plants, and there's the floating plants, and then there's the simple question of was there weed management. And it'd be interesting to see what happened to your scores before and after. So it wouldn't be that much of a time commitment. I think you would just have to drive around the lake one more time and change all your answers and then see what happens. So this is the first year we're really doing this, so it would be interesting to me if you would try that out and let me know how that ended up affecting what you saw. Will do. Okay, thank you, Linda. So thank you very much for attending this training. If you have another question, now is your chance. Type it out. If it's a long question, type wait, 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 and then we'll know not to leave, and we'll give you a chance to type more. But otherwise, we'll plan on checking out here in just about 20 seconds or so. So thank you all very much for attending, and good luck in your monitoring this summer. If you have questions, email me. There's my email right up on the screen, my phone number, and I'll answer your questions to the best of my ability, or get Joe Lattimore to answer them. So thank you all very much.
And we put the website up here on this last slide in case you would like to view any of these videos again on your own time. And we'll also be following up by emailing you, I guess I misspelled that, a follow-up survey. So please keep your eye out for that in the next day or so, and we would like to hear your thoughts so we can make improvements for next year.
Okay. All right. Thank you, everyone. Have a good night.
Thanks, everyone.